guys, in this video we're going to continue with our explanation of how to use a cos diagram in specific situations. So for this video, a situation that we're going to look at is if they give you a trigonometric ratio, for instance, and then they say, let's say sin 36 degrees is equal to 4/5. And then the question wants you to give cos 36 degrees without using calculator. Yeah, with a calculator, I mean, you just plug this in, it's simple as that. But this time around, they don't want us to use a calculator and they just give us this specific information. This is a very simplistic example. We will look at more complicated examples, but this example will kind of get you in the right direction in terms of understanding what is going on. So immediately when you get this sort of question where they give you one trigonometric ratio and then they want you to solve another trigonometric ratio without using a calculator, right off the bat you draw a cos diagram at the side of your paper or somewhere. It's going to be very important. And so we're going to be looking at the given information. Let us work with the given information first. So sine 36 degrees, how are we going to represent it in a cos diagram? We're going to represent it in a triangle form, right? So 30 degrees is between 0 and 90 degrees. So essentially it would be over here. So with this, whenever you're going to draw a triangle in a cos diagram, in this Cartesian plane, you want to make sure that at the beginning, the line that you're going to draw, that is the hypotenuse, the line that spawns from the middle over here, whether you're going to draw it there or there or there, depending on your angle, right? In this case, it's 36 degrees, so just simply drawing it there. That is your hypotenuse, that is your longest side, right? And then to complete the triangle, you simply just pull the line down vertically, pull it down vertically. Don't do this. Don't draw the missing side horizontally. Now there is no harm in doing this, but it is going to cause so much complications. You always, when you draw a triangle for the given information, when the trigonometric ratio is involved, you always want to make sure that the final length, you pull it down horizontally so that it is perpendicular to the x line. You want to make sure that the final line is perpendicular to the x line. Your triangle must always look like this. We don't want to see it look like this, just like how I demonstrated it. We don't want to do it. It can work, but now you're gonna have to change your perspective on how you're going to look at it, because if you're going to draw it like this, your angle 36 degree is going to end up here, and it's just going to be a mess. It's just going to be a mess. So rather and you will see what I mean later onwards. So just rather to complete the triangle, always pull the line down. So for instance, if we were given, let's say sin 108 degrees, let me erase this. 108 is somewhere here. This is 108 degrees. This line, you always pull it down so that it is perpendicular to the x line. So this is how you always want your triangle to be. You don't draw it there. We don't want to look at it that way, right? So always remember that for every triangle you're going to draw in a cos diagram, given the trigonometric ratio, you always want to make sure that the final missing line, pull it down so that it is perpendicular to the x-axis. So now going back to our original question of sine 36 degrees. So we know that with sine, it's x over r. No, not x, y over r. My bad. Or opposite over hypotenuse. It doesn't matter how you want to see it. Opposite over hypotenuse or y over r. In this case, let us use the y over r for Cartesian plane purposes. We know that this is the y, right? This is the x. So this line over here, this is the y. And the r is always the hypotenuse. The r is like, think of it as a radius. Yes. But it's also the hypotenuse. So the radius is the hypotenuse. So that is r. And in this case, 4 is our y, right? As we can see there. What is r? 5. Cool. So now that we have plotted our information, which is sine 360 degrees is equal to 4/5. Over here, now the question says, what is cos 36 without using a calculator? Okay, what do we know about cos? Cos 36 in this particular situation would be x over r, or adjacent over hypotenuse, however you want to write it. But for this example, let us stick with x over r. X is this line over here, so it's going to be this side. X, so it's going to be x over 5. How can we solve for x? Look at this triangle. It's a right angle triangle, right? So we use good old Pythagoras to solve for x. So 5 squared minus 4 squared is equal to x squared square root damn. It's 25 minus 16. What is that? Square root 9, which is x. X is equal to 3. We know that when we square root, you're going to end up with a plus or minus. But if we look at our Cartesian plane over here, this x, it's on the positive side of the x line, right? And so the answer that we're going to end up with is positive 3. So x is positive 3. That sign is important. If this triangle was the other way around over here, maybe it was, yeah, then it was gonna be negative x, right? And so we will probably get a different x over there. So you also want to pay attention to your signs when working on a Cartesian plane. And so now that we have this, we can go ahead and say that cos 36 degrees is equal to 3 over 5 without using our calculator, right? Had we use our calculator, I mean, look, when you type this in your calculator, you're not gonna get this. This is just from an example. This is not an accurate depiction that it is. Sine 36 degrees is not really 4 over 5. This was just for the sake of an example. Keep note of that. And so cos 36 won't really be this, but this is just a made up question just so that I can go ahead and explain as to how you want to use the cast diagram where you're going to be getting these sort of questions. So just a disclaimer, sine 36 is not 4 over 5, please. And cos 36 is not 3 over 5, just in case you want to verify with your calculator. You're going to get something different, right? And yeah, I will see you guys more on the next video as I'm going to explain more on these concepts of using cast diagram. Thank you.